Tri-State Wire Rope is a leading supplier of wire rope, serving the heavy industries such as construction, transportation, oil and gas, and marine. The company is known for its superior product quality, compliance with international safety standards, and providing a wide range of wire rope solutions, including professional wire rope splicing services. For the 1-1/2 inch wire rope splicing process, Tri-State Wire Rope implements a rigorous process to ensure maximum durability, safety, and performance for the finished product. Before splicing, Tri-State Wire Rope always thoroughly checks the input materials. The selected 1-1/2 inch wire rope must meet high tensile strength and load-bearing capacity standards. The company uses specialized accessories such as aluminum or copper ferrules, cable clamps, and cable sleeves. The technical team will carefully inspect the cable surface to ensure there are no signs of corrosion, fraying, or damage before proceeding. The cable is precisely cut using a specialized hydraulic cable cutter, ensuring accuracy and cleanliness at the cutting point. To prevent the cable from coming loose after cutting, the cable ends will be treated by welding or applying anti-corrosion glue. This helps protect the cable ends and ensure the integrity of the cable structure in the following steps. An important step in the cable splicing process is ferrule splicing. This technique uses a metal ferrule to join the two ends of the cable together or create a loop. The cable is threaded through the ferrule and forms an I-splice or a straight connection depending on the requirements. The technical team will carefully inspect to ensure the cables are inserted correctly, without looseness or misalignment. Ferrule connector compression by swagging technology. The connector compression process is performed by a specialized hydraulic press, hydraulic swagger machine. This process creates a huge pressure, compressing the ferrule tube tightly around the cables inside, helping to create a strong and non-removable joint. After compression, the joint will be carefully inspected to ensure there are no signs of abnormal deformation or cracks. Tri-State Wire Rope applies strict quality control standards to ensure the highest durability of the joint. The company performs static load testing by pulling the joint under a tensile force twice the normal working load. In addition, technicians also visually inspect and perform ultrasonic testing to detect hidden defects inside the joint, ensuring the product is absolutely safe when put into use. After the joint passes the inspection steps, the cable will be completed by wrapping an additional protective layer such as PVC or anti-corrosion tape to increase durability and service life. In addition, the wire rope is fully labeled, including the safe working load, WLL, production date and inspection lot number for easy tracking during use. Tri-State Wire Rope is committed to providing full technical certification after completing the cable splicing process. Customers will receive a quality inspection report and a certificate of joint strength according to international standards such as ASME B30.9 and OSHA. Tri-State Wire Rope stands out with its advanced technology and highly automated production process. Modern machinery ensures precision in every detail, while a team of highly skilled technicians optimizes product quality. The company also focuses on sustainability and environmental friendliness during the production process, while ensuring products are durable, safe, and suitable for the harshest working conditions. Mooring at sea presents significant challenges due to constant movement from waves, wind, and currents. Connections must absorb shock loads and maintain strength under these dynamic conditions. Standard knots are insufficient. Specialized methods are essential. The key principles are load distribution, aiming to distribute the load evenly across the rope or cable to minimize stress on any single point. Friction and binding, where friction plays a role but secure binding and seizing are crucial for heavy loads. And material compatibility, using compatible materials for ropes, shackles, and hardware to prevent corrosion and premature wear. Several methods are used to create these strong connections. I-splices with thimbles create a loop in the rope's end. Inserting a thimble, a metal or plastic loop, protects the rope from abrasion and distributes the load over a larger area. For heavy mooring, multiple tucks are used in the splice for maximum strength, and the thimble is often secured within the splice using seizing wire. This eye is then connected to a shackle. Shackles, U-shaped metal connectors with a removable pin, connect ropes to other hardware or mooring points on the ships. Connecting links, also called joining or pair links, join two lengths of chain or wire rope and are stronger than simply shackling two eyes together. Using properly sized shackles and connecting links with sufficient working load limits, WLL, is crucial. Often, a combination of chain and wire rope is used. Chain offers excellent abrasion resistance, especially near the seabed or ship's hull, while wire rope provides flexibility and strength for longer spans. The connection between chain and wire rope is typically made using a connecting link or a specialized shackle. Modern mooring frequently uses high-performance synthetic ropes of HMPE or aramid fibers, offering high strength-to-weight ratios, good abrasion resistance, and low stretch. These ropes are often terminated with specialized end fittings like resin-potted sockets or soft eyes to maximize strength and minimize stress concentrations. In a simplified example of ship-to-ship mooring, each ship prepares mooring lines, possibly consisting of wire rope with an I-splice, thimble, and shackle. Smaller messenger lines are used to initially pass the mooring lines between ships. Once a messenger line is received, it pulls the heavier mooring line across, and the shackles are connected, often using a connecting link. Finally, the mooring lines are adjusted using winches and other equipment to achieve the desired spacing and tension. The mooring is then continuously monitored for changes in conditions, and adjustments are made as needed. This is a simplified overview. Actual ship-to-ship mooring is a complex operation influenced by factors like ship size, weather, sea state, and operational requirements. It demands careful planning, skilled personnel, and appropriate equipment. It's not about simple knots, but creating engineered connections designed for extreme loads. Daiko Corp., a leading Japanese manufacturer, specializes in wire ropes, steel wires, and related products. The wire rope manufacturing process begins with wire drawing, the foundational step. High-carbon steel rods are drawn through a series of progressively smaller dies, reducing their diameter, increasing their length, and significantly boosting their tensile strength. Multiple passes through drawing machines are typically necessary, sometimes interspersed with annealing, a heat treatment process that relieves internal stresses and improves ductility. Next is strand formation, where the drawn wires are twisted together to form strands using stranding machines. These machines rotate spools of wire at precise speeds and tensions. The number of wires per strand, their lay, the direction and angle of the twist, and the core material, steel wire, fiber, or a combination, are determined based on the final wire rope's requirements. Different stranding machines, including tubular and planetary types, are used depending on the desired strand construction. The final stage is rope closing, where the pre-formed strands are twisted around a core to create the complete wire rope. This is done using closing machines, which are similar to stranding machines but larger. The closing process determines the overall rope diameter, its lay, the twist of the strands, and its compactness. The core provides support for the strands and influences the rope's flexibility and resistance to crushing. After closing, the wire rope may undergo finishing processes such as pre-stressing to remove constructional stretch, lubrication to reduce friction and corrosion, and coating like galvanization for corrosion protection. Rigorous inspections then ensure the rope meets all quality standards and specifications. Their focus on precision and innovation at each manufacturing stage, from wire drawing to final inspection, contributes to the reliability and durability of their products. Gabas Al-Balad Wire Rope Factory is one of the leading wire rope manufacturers in the region, supplying wire rope to the oil and gas drilling industry and heavy industries. The company is known for its application of modern technology and maintaining high-quality standards in each product. With strict production processes and a team of experienced technicians, Gabas Al-Balad has built a solid reputation in the international market. The production process of wire rope at Gabas Al-Balad begins with the selection of high-quality raw materials. Carbon steel is the main material used to ensure durability and strength. Every batch of raw materials undergoes a thorough chemical and mechanical testing process to ensure that it meets the standards for tensile strength, elongation, and corrosion resistance. Once the raw materials are tested and qualified, the wire drawing process is carried out. The raw steel is drawn into smaller wires through a die system using a multi-stage wire drawing machine. This process reduces the diameter of the steel wire, increasing the hardness and durability of the product. To minimize friction and heat generated during this process, Gabas Al-Balad uses a modern cooling and lubrication system. Next, the steel wire will undergo a heat treatment process to improve mechanical properties such as toughness and hardness. Treatment methods include annealing to reduce stress in the wire, as well as quenching and tempering to strengthen the sustainable structure. Thanks to that, the steel wire reaches optimal hardness and durability, suitable for harsh working conditions in the oil and gas industry. To protect the steel wire from oxidation and corrosion, Gabas Al-Balad performs a galvanization process. The steel wires will be dipped in a molten zinc bath, creating a durable protective coating. In particular, the company applies the hot dip galvanizing method combined with the air knife system to control the thickness of the zinc layer, ensuring high durability for the cable in harsh environments. After completing the processing steps, the steel wire is transferred to the stranding stage. The steel wires will be stranded according to specific technical designs, forming a complete cable. This stage is performed by a multi-strand stranding machine with an automatic control system, ensuring high precision and uniformity in the wire structure. Product quality is the top priority at Gabas Al-Balad. The quality testing stage is strictly carried out, including testing for tensile strength, torsion, fatigue strength, and corrosion resistance in harsh environments. After meeting quality standards, the products will be carefully packaged, rolled, and protected before being shipped to customers worldwide. The wire rope manufacturing technology at Gabas Al-Balad is characterized by a high level of automation, ensuring maximum efficiency and precision at every stage. The rigorous quality control process, combining manual and automatic inspection, helps the product meet international standards. In addition, Gabas Al-Balad also focuses on environmental protection by applying energy-saving production technologies and minimizing waste. Hydro Group, based in Aberdeen, Scotland, is a leading global company specializing in the design, engineering, and manufacture of subsea cable systems. The manufacturing of subsea armored cables at Hydro Group begins with conductor production, where highly conductive materials like copper or aluminum are drawn into wires of specific diameters to form the cable's core, responsible for carrying electrical current or signals. Each conductor then undergoes insulation with specialized materials such as polyethylene, PE, or cross-linked polyethylene, XLPE, to prevent electrical leakage and maintain signal integrity. These insulated conductors are bundled and protected by an inner sheath. A crucial step is armoring, providing mechanical protection against abrasion, impact, and external pressure. Hydro Group employs various techniques, including steel wire armor, where galvanized steel wires are helically wrapped around the inner sheath for high tensile strength and mechanical stress protection. For extremely harsh conditions, double armoring, using 2 layers of steel wire, offers enhanced protection. The final layer is the outer sheath, typically made of robust materials like high-density polyethylene, HDPE, or polyurethane, PU, providing further protection against seawater, chemicals, and UV radiation.